Imagine a time machine so powerful it can look back billions of years, to the very dawn of time when the first galaxies and stars were just beginning to form. This isn't science fiction. This is the James Webb Space Telescope, humanity's most advanced window to the early universe. Today, we're going on a journey through time and space to witness the cosmos as it was billions of years ago. When we look up at the night sky, we're not seeing stars as they are right now. We're seeing them as they were in the past. The light from the closest star, Proxima Centauri, takes over 4 years to reach us. So, when we look at it, we're seeing it as it was 4 years ago. Telescopes like the James Webb Space Telescope take this concept to the extreme. When we observe galaxies that are billions of light years away, we're seeing light that has traveled for billions of years to reach our telescope. In essence, JWST is a time machine, allowing us to witness the universe's history unfold. The farther we look into space, the further back in time we see. This is where JWST's real superpower comes in. Its ability to observe in infrared light is the key that unlocks the ancient universe. As the universe expands, the light from the most distant, earliest galaxies gets stretched out. This stretching process, called redshift, shifts the light from the visible spectrum into the infrared. So, to see these first galaxies, you need an infrared telescope. Webb's incredible sensitivity to infrared light allows it to capture this faint, stretched light from the dawn of time, revealing how the cosmos evolved from its fiery infancy into the grand, structured universe we see all around us today. Why is infrared so special? Think of it like a pair of magic glasses. Visible light gets blocked by the vast clouds of cosmic dust that fill our universe, but infrared light can pass right through them. This means JWST can peer into regions that are completely hidden from other telescopes like Hubble. It can uncover galaxies that were previously invisible, see into the heart of dense stellar nurseries where new stars are being born, and even analyze the atmospheres of distant exoplanets. To do this, JWST needs a massive mirror. Its primary mirror is over 21 feet across and coated in a thin layer of gold, which is excellent for reflecting infrared light. This giant mirror acts like a light bucket, collecting the faint photons that have journeyed across billions of light years from the universe's earliest epochs. This incredible combination of a huge mirror and infrared sensitivity makes JWST the most powerful cosmic time machine ever built, giving us an unprecedented look at our universe's origins. Getting this observatory into position was an engineering marvel in itself. Launched on Christmas Day 2021 aboard an Ariane 5 rocket, JWST embarked on a 1 million-mile journey from Earth. Its destination was a special spot in space known as the second Lagrange point, or L2. Here, the gravitational pull of the Sun and Earth balance out, allowing the telescope to stay in a stable orbit, shielded from Earth's heat and light, giving it a clear, unobstructed view of the cosmos. But the journey was only half the battle. The telescope's massive mirror and its tennis court-sized sunshield had to be folded up like origami to fit inside the rocket. Once in space, they had to deploy perfectly. For nail-biting weeks, engineers on the ground carefully commanded and monitored every step of the complex unfolding process. When the final mirror segment clicked into place, Mission Control erupted in cheers. This successful deployment marked one of the greatest engineering achievements of our time, opening a window billions of years into the past. So, what has this time machine shown us? JWST is capturing light from galaxies that formed just 300 to 500 million years after the Big Bang, a mere blink of an eye in cosmic terms. These are the baby pictures of the universe. Some of these early galaxies are tiny, faint, and clumpy, just as theories predicted, but others are surprisingly massive and well-structured, challenging our ideas about how quickly galaxies could form and grow. Studying their shapes, sizes, and chemical compositions helps scientists piece together the story of how the first cosmic structures came to be. These ancient galaxies are the fundamental building blocks of everything that followed, including our own Milky Way. Every new observation is another piece of the grand cosmic puzzle. Beyond seeing the first galaxies, JWST's infrared vision allows it to peer deep into the stellar nurseries where stars and planets are born, regions hidden behind thick curtains of cosmic dust. In these chaotic, beautiful clouds, gravity pulls gas and dust together until new stars ignite, blazing into life. We can now observe these processes happening in incredible detail, even in galaxies billions of light-years away. By watching stars and planets form in the early universe, we get a glimpse into how systems like our own solar system might have originated. With JWST, we are direct witnesses to the birth of stars and the formation of new worlds, seeing it all unfold as it happened billions of years in the past. And this time machine doesn't just look at stars and galaxies. It can also study distant worlds orbiting other stars, known as exoplanets. When an exoplanet passes in front of its star, a tiny fraction of the starlight filters through its atmosphere. JWST can analyze this light using a technique called spectroscopy, breaking it down to reveal the chemical fingerprints of the molecules within that atmosphere. Scientists can detect water vapor, clouds, methane, and other key chemicals. This incredible capability allows us to study planets as they were forming billions of years ago, giving us clues about their potential for hosting life and shedding light on the origins of habitable worlds across the cosmos. In just its first couple of years of operation, JWST has already delivered a treasure trove of breakthrough discoveries. We've seen stunning deep-field images revealing thousands of galaxies that were completely invisible before. We've discovered some of the most distant galaxies ever observed, pushing the boundaries of what we thought was possible. Some of these objects formed much earlier and grew much faster than astronomers expected, forcing us to rethink our models of the early universe. Each image is a time capsule, a snapshot from a forgotten era, offering unprecedented insight into cosmic evolution. These discoveries are already rewriting textbooks and inspiring a whole new generation of astronomers. Behind every breathtaking image is an incredible story of human ingenuity and collaboration. The James Webb Space Telescope is the product of decades of innovation and perseverance. It was built through a partnership between NASA, the European Space Agency, and the Canadian Space Agency, representing a true triumph of international teamwork. To build a machine this complex, deploy it flawlessly a million miles from home, and have it operate perfectly is a testament to what humanity can achieve when we work together to explore the great unknown. The James Webb Space Telescope is so much more than a piece of hardware. It's our time machine to the dawn of the universe. From the most distant galaxies and newborn stars to the atmospheres of alien worlds, it's revealing our cosmic story as it happened billions of years ago. It reminds us that the universe is vast, mysterious, and full of secrets waiting to be discovered. Thanks for joining this journey through time. Stay curious and keep exploring.